Hello and welcome back to another video. In today's video we are going to be adding a buzzer to our circuit and then learning how to do some basic programming with it in Arduino. Now as you can see, we have two things in front of us. We have the buzzer on the left hand side and we have another resistor on the right hand side. So we're going to be using these two parts to add a buzzer circuit into our Barnabas noggins. Now the buzzer itself is a lot like the LED in that it wants to be oriented a certain way in our circuit. So it wants one side to always be on the positive side of the circuit and one side to always be on the negative side of the circuit. So how do we figure out which side goes on which end of the circuit? If you look near the bottom side of its face, I'll make sure that I highlight that, there is a little circle and a plus sign inside of it. Now that plus sign is standing directly on top of one of the two legs, and that is indicating the leg that is the positive leg. It belongs on the positive side of the circuit. So this is unlike the LED in that the LED just indicated by a difference of the length of the legs. This one instead is directly telling us, hey, this is the positive leg. So we'll need to make sure that we remember this and we keep track of that plus sign as we're adding our buzzer to our Barnabas noggin. Alright, so here's our Barnabas noggin as it currently is. Notice that it's not plugged in because I plan on putting a little bit more hardware on it. I plan on creating another circuit right now. So for safety's sake, I want to go ahead and leave it unplugged. Now, if you remember in the last video, we had a couple of specific spots that were already on the breadboard for us to put our LED and our resistor. So we had designated spots that were already there for that purpose. It's the same way with the buzzer. So if you look carefully at your Barnabas noggin, you'll notice an area that is labeled as buzzer 6. And you'll notice another area that's labeled as R2. So R2 means resistor 2, so that'll be where we place our resistor. Buzzer 6 refers to the pin number that the buzzer is on, and obviously that's going to be where the buzzer goes. And if you look closely at that buzzer area, you'll see a little plus sign next to one of the holes for the legs. So it's letting us know, hey, put the positive leg in this hole. Alright, so without further ado, let's wire the circuit. I'm going to go ahead and start with the resistor. Alright, that's in there. And then the buzzer, we need to make sure that the plus sign, it's on this side for me, is oriented so that it is aligned with the plus sign on the Barnabas noggin. So I have the positive leg on the right side. And there we have it. So I'm going to go ahead and plug this guy in and get into Arduino, and I'll see you guys when I get there. Alright, so here I am back in Arduino, and as a reminder, first thing I want to do is check my port. I know I'm on COM4, Noggin, that's right for me, Barnabas bot, yes, and then I'm going to also grab the loop tube. Now there is a lot to talk about, kind of a preamble before we get into actually coding with the buzzer. The buzzer is a complicated part, and how you generate sound from an electrical part in general is a little complex. I think it lies beyond the scope of this video, so I'm not going to delve too deep into the science behind, how the buzzer is creating sound. We're just going to focus on how to functionally use the buzzer. So that being said, I'm going to go into the Sounds tab. I'm going to grab this tone block, and I'm going to change this to pin number 6. So remember that we had our buzzer on pin 6. That area was labeled buzzer 6 to let us know that it was on that pin. So this should be able to control our buzzer. We're telling pin 6 to have a frequency of 440. So the frequency refers to the pitch of the sound the buzzer is making. So we can make a lower number for a lower pitch, a deeper pitch, or we could have a higher number for a higher pitch. Keep in mind though that the buzzer doesn't have a very wide effective range. It's going to start to behave a little weird. It'll make sounds still, but it won't make, very high quality sounds outside of the 200 to 800 range. So you may want to keep that in mind. Of course, you can take it to the limit. You can make the number in here as ridiculous as you want. You're not going to break the buzzer. It's just going to give you a very odd sounding thing instead of, a nice single tone. As a matter of fact, these tones can be related back to musical notes, but we will get into that in a later video. So for now, all I'm going to do is just try and upload this and see what happens. So you should be able to hear the sound of the buzzer as this finishes uploading. You guys hear that? I think you guys get the idea. I'm just going to upload blank code to get rid of that noise for now. What I want you to know is that the frequency, this guy here, changing the frequency does not increase or decrease volume. Frequency is not the same as volume. The only way to change your volume effectively would be to use a different resistor. So if R2, that resistor, was a stronger resistor, it would make a weaker noise, and if it was a weaker resistor, it would make a louder noise. The other thing you can do is just cover the top part of the buzzer with your finger, and that'll somewhat mute it. So with that in mind, let's go ahead and let's try and alter frequencies. So I'm going to go ahead and upload the 440 frequency again, just so we can hear it. And then I'm going to change it to, I'm going to change this to 261. So this is a distinctly different frequency, or it will be. So this one is substantially lower if you can hear the difference. Yeah, I'm going to, it kind of sounds like, I don't know. This sounds like a bunch of bugs at night. Anyway, a more effective way to kind of see the difference between those two frequencies is to maybe do them side by side. So I'm going to put a low and high frequency together in the same program. So I'm going to go ahead and go back into sounds, go to tone, pin 6, this one's 440, so I have 261 and 440. So I have two distinctly different tones that I'd like to separate by a couple weight blocks. I would really like to distinctly hear one of these tones for a second and then the other tone for another second. So I'm going to go ahead and upload this. So we've got kind of like a siren type situation going on. So we could change the delays here if we would like to. I might do that a little later to show you a little something. So you can use the delays to augment sort of how fast your siren is going. In addition, we have this no tone block, and it does exactly what you would expect. It'll get it to stop making noise. And in this code that I have here, I'm just going to leave this guy off to the side, but in the code in the loop do, I have frequency 261 happening for a second, and then the buzzer turning off for a second before it goes back on. So this will effectively give us like a start and stop. So before we take off, I want to show you something that I like to do just with what we've learned today. I'm going to make a couple extra. I'm going to get rid of this guy. We don't need him. And let's see here. So I have 261, 440. How about 600? I'm just kind of coming up with numbers at the top, off the top of my head. Not really thinking too much about it. How about 323? Sure. So I have 4 different frequencies, and they kind of alternate between, well, not quite, but there's some high frequencies, some low frequencies, and I'm going to shorten these delays quite a bit. How much do I want to shorten these delays by? I think I'm going to put them all the way to 0.05. I'm going to make them very short. I can always change these later. It doesn't take too much effort to change these numbers. So this is, instead of 1 second, it's 1/20th of a second. And I just want to kind of show you how significant the effects of changing your delays are, or I'm sorry, your weights, when working with the buzzer. So that's the kind of thing I get if I choose to have such a short delay. So that is all I have for you today. In the next video, we're going to be jumping into creating music, yes, actual music, instead of just noise with this buzzer. So I hope to see you in the next video.